Hi. In this two-part series, we'll talk about visualizing with technology for mathematics. The first part will deal with school mathematics. The second part will deal with the visualization and the technology. But across the two videos, we'll look first at school math and standards, particularly as they connect or don't connect to real-world math in a 3D world. The second video will deal more with the way mathematics and science have changed one another in recent years, some of the math tools for dealing with that change, and ways of thinking mathematically using technology. So let's look at school math. When I taught 9, 10, and 11-year-olds, this is the kind of math they were doing. They learned addition, subtraction, multiplication, and division of multi-digit numbers. And it was all paper and pencil. So this is what they were taught. To check the answer, what were they told to do? Oh, turn the problem upside down and add it again. In other words, the check took as much time as the problem itself. I taught them a simpler system that gave almost every student an A in the units that dealt with these topics. Let's see how that worked. So I would use something called a digit sum system, and let's see. Okay, so I'm taking something called the digit sum of each line, and then I sum these together, and let's see what I get. And then the digit sum down here. I got a pair of 7s, which means there's a 90% chance that my addition is correct. Now, if you don't know what the digit sum system of mathematics is, you have not been taught mathematics well, because mathematics is the simplest way of doing addition with paper and pencil and checking it in a simple way. Let's look at a much better example. This is a complex problem. How are kids taught to check this? They're told, oh, just reverse the two numbers and multiply again. Well, if a kid has trouble with 4 times 8, the kid will have trouble with 8 times 4. So again, a digit sum method of doing this would be okay, and then my digit sum across the bottom. So that quickly, I've checked this, and again, to a 90% probability, my multiplication is correct. This would give students nearly perfect scores on standardized tests, on unit tests, whenever they do multi-digit operations. Why isn't this taught in school? My guess is that school curricula in mathematics is backward-looking. The way we did it 10 years, 20 years, 100 years ago is the way we do it now, and no one is looking at any opportunity to improve. So you may think that, well, this is an issue of paper and pencil versus 21st century problem, computer versus paper versus pencil. But let's take a look at another example. So the word triangle is not a hard word for kids to pronounce or spell. One of the first things kids learn in school are the kinds of triangles. Now, right triangle isn't bad, although we could call it something like a square corner triangle and be perfectly transparent about it. But equilateral triangle triples the challenge of just the word triangle. And isosceles, for kids to spell and pronounce that, is ridiculous when it's such a simple concept. And when have you ever heard or used the word scalene before plane geometry class and after? If there's not a term that you will ever use, why test it? Why teach it? But that's not the worst of it. So we're taught that, oh, the angles of a triangle add up to 180 degrees. Yeah, except if you're traveling in a triangle. So imagine you're programming a robot moving to the left, and then the robot needs to turn, and that would be a 130-degree turn. Moving up here, turn again, but wait a minute, 130 plus 110 is 240. That's already more than 180. This is a triangle. What's wrong with what's going on here? It turns out that these are exterior angles. So sometimes we deal with interior, sometimes we deal with exterior. Same rule though, the angles of any shape when you come back to your starting position add up to 360 degrees. But we emphasize one and test one little tiny rule and ignore all the other reasons why that rule may lead someone astray. So that's just plain stuff that we can do in paper and pencil, and there are flaws. How about a 3D world? So, oh, this is a nice little cube. So let me draw this. Is that a circle or is that a sphere? How do you draw a sphere on a piece of paper? There are no little dashes that you can do to show hidden lines, are there? And we have all these fine formulae for the simplest possible 3D object. We'll see in the next video ways of dealing with the 3D world in powerful ways.